Hello everyone and welcome back to the channel. In almost every modern system, applications aren't built as monolithic blocks anymore. They are composed of many independent services that need to talk to each other. How do they communicate? How do they communicate? They communicate through APIs, which is application program interfaces. In system design interviews, discussing APIs isn't just about knowing what they are, it's about designing them effectively and efficiently to ensure modularity, scalability, and robust communication. Today, we are diving into why APIs are central to system design interviews, and it's the key aspects you need to master. Okay, so before we talk about anything, we need to understand what is an API. So at its core, an API is a set of rules of or maybe specifications that defines how different software components or systems should communicate and interact with each other. Think of it like a menu in a restaurant, like it tells you what dishes you can order, how to order them, and what kind of meal to expect in return. It hides the complexity of the kitchen, which is the underlying implementation, but provides a clear contract for interactions. APIs are the glue that holds together our distributed systems, enabling modularity, integration, and abstraction. So, if you want to wonder why the client and the server can communicate effortlessly in the best way possible, this is thanks to our API. Okay, let's try to talk next about why API matters. After that, we just talk about some important aspects, and in the end, we'll talk about how you will use APIs in your system design interviews. So, why does API matters? First, modularity and loose coupling. Like well-defined APIs allow different services to be developed, deployed, and scaled independently without knowing the internal working of other services. This promotes a loosely coupled architecture. Number two, integration. APIs are the bridge for connecting disparate systems, whether they are internal microservices, external third-party services, or different client applications like web or mobile. Number three, abstraction. APIs hide the underlying complexity. A client doesn't need to know how data is stored or computed. It just interacts with the API endpoints. Number four, scalability and evolution. A well-designed API that is stateless and versions can easily support scaling out backend services and allows individual services to evolve independently without breaking clients. Lastly, security. APIs define the access point to your system, making them critical for implementing authentication, authorization, and rate limiting to protect your resources. Okay, let's talk about some key aspects of API design in system design interviews. Number one, we will talk about the API style protocol, and this is important. We have three things. We have REST, we have GraphQL, and we have gRPC. So let's start with REST. REST is short for representational state transfer. This is the most common and often the default choice for web APIs. It's stateless, uses standard HTTP methods like get, put, delete, post, things like that, and focuses on resources like slash users, slash products, things like that. It's the pros of it. It's a simple leverage web standards, easy to cache, and widely understood. The cons of REST API, I would say it can lead to overfetching, like getting more data than you need, or underfetching, which is needing multiple requests for related data. But you can fix this in the back end as well. Number two, we have GraphQL. QL. So GraphQL, which is a query language for your API, clients define the exact data structure they need, and the server returns it precisely. Sorry. The pros of it solves under an overfetching problem. It has a single point and it has a strong typing. The cons of it can be more complex to implement and cache. It's not inherently tied to HTTP verbs. And lastly, we have gRPC. Okay, it's a remote producer call. It's a framework that uses a protocol buffer for serialization and HTTP/2 for transport. The pros of it, it's high performance binary HTTP. It has high performance like binary or and HTTP/2 multiplexing. Also, it has header compression, strongly also typed interface, and lastly supports bidirectional streaming. The cons of it is steeper learning curve. It's not that easy. Requires IDL, which is interface definition language, and completion, and also limited browser support. It's not that easy to be limited. Next, we have WebSockets. WebSockets is just for real-time bidirectional communication, or maybe message queue for asynchronous communication. And I will talk about them in a bit. I will talk about WebSockets and message queues. We will create dedicated videos only for that. Okay, we have here data formats. There is JSON, XML. Yeah, this is the only two things that you can think about. Maybe or like protocol buffers. JSON is like short for JavaScript object notation, which is the overwhelming standard for web APIs due to its human readability and widespread. There is an XML. It's less common now, but it's still used in some enterprise systems. Next, we have authentication and authorization. Basically, it's how clients prove who they are and what they are allowed to do. Like there is an API keys, which is simple for public limited access. There is OAuth 2, which is a standard for delegated authorization. There is a JSON Web Token, which is common for stateless authentication between microservices or client service. There is versioning, like how you manage. Lastly, we have versioning here. Not lastly, I guess we have two more things. Sorry. We have here versioning. Basically, it's how you manage changes to your app, to your API over time without breaking the existing clients. So, for example, you will have like something like that v1/user, and maybe you have like v2/users, things like that. You can think about like that. And we have here error handling. Okay, so how your API communicates problem, like using HTTP status codes, like 400 is bad request, 401 is unauthorized, 403 forbidden, 404 it's not found, 500 is internal server error, and so on and so forth. Lastly, we have rate limiting. So it's protecting your API from abuse or sudden traffic spikes by limiting the number of requests a client can make over a period. Okay, let's talk about how to discuss APIs in your system design interviews. Like when discussing APIs in a system design interview, you need to think about some things. First, I would say that justify your choices. Like don't just say I would use REST API. Explain why REST fits this particular use case. Maybe for external public APIs, REST is a good choice due to like its simplicity and HTTP standard adherence, things like that. Or for internal microservices, maybe like gRPC might be better for performance and strong typing, things like that. Always justify your choices. And I would say that this is not related only to discussing API in system design interviews. This is related to any choice you will make. Number two, consider internal versus external APIs. And this is quite crucial, guys. External APIs need more robust authentication, stricter rate limiting, and care for versioning. Internal APIs might prioritize performance or specific data types. Number three, I would say mention an API gateway. Yeah, that's one of the important things. Please mention it. Like instead of typing, yeah, we need a load balancer. No, put I will need an API gateway, because an API gateway acts as a load balancer. It acts as a rate limiter, acts as an authorization service, and also it makes formats for the data. So again, how it can centralize authentication, rate limiting, routing, and potential transform request for your backend services. Also discuss trade-offs, like every API style has pros and cons. Acknowledge them. For example, why GraphQL over flexibility and can complicate caching at the CDN levels. For example, lastly, always include security. How would you authenticate, authorize, protecting against common attacks, things like that. So yeah, guys, that's it for this video. If you like this, if you find this video helpful, please like, subscribe, and hit the notification bell so you never miss any video. And see you in future videos.